Well, hi there, boys and girls. I hope everybody is doing okay. I wanted to give you just a little, I guess, kudos for today. I really enjoyed watching you guys learn some new stuff today with graphing your polynomials. I know I've been sort of hard on you about the factoring because it's so important, but today I really saw a lot of you just learn something new and just grab a hold of it really, really quickly, and you really showed me what kind of pre-AP students you were. It really made me happy. I just wanted to give you guys a shout out, everybody a shout out for that, because I enjoyed that. You guys learned something new that you've never seen before, and you just grabbed a hold of it. Okay, so today what I want to talk about is what happens between the roots. How do we tell how far a graph goes up or down, and what these things are called? We're going to be using a graphing calculator, but before we get started with that, I want to get some terminology out of the way. Terminology, I'll say that 3 times fast. The terminology I want to talk about is something called local extrema, and this is a fancy word for max and mins, locally max and mins. Or does the graph turn? And if it does turn, where does it turn? As the graph turns. So anyway, this is what we're going to figure out. We're going to figure out, does the graph turn, and if it turns, where does it turn at? When something turns, it's going to create a local extrema, and we're going to call this a max or a min. And the reason we're going to call it local is because if I look in this neighborhood on this point of negative 3, 2, if I look a little to the left and a little to the right, that red dot is the tallest locally. That's the tallest dot there. This is called a local max, because in this little window here, there's not another dot on the graph that's taller than that. That's because the graph turned there. We're going to call that a maximum, or just a max for now. And then the second point, negative 1, negative 3, is where the graph turned, and it created what's going to be called a local minimum. It's a local min because locally, or in this little neighborhood, there's not another dot that is lower than that. And then here is a local max. And then this last one, this is a local min. So here's what I would say. I would say this graph has a local max of negative 3, 2. It tells, the negative 3 tells where it happens on the x-axis. The 2 is actually the y value. So we're saying around negative 3, this graph never gets taller than 2. 2 is like the highest point. Then the second one, I would say this graph has a local min at negative 1, negative 3. The negative 1 tells me where it happens on the x-axis. The negative 3 tells me, what is that minimum value. So then we have a local max of 1 when x equals 2, and a local minimum of negative 1 when x equals 4. So let's go look at one that's not labeled. So here we've got a graph that turned once, twice, 3 times, 4 times, 5 times. Let's label these. This is a local maximum, and it happens at 3, 4, 5, negative 5, 1. And then here is a local minimum, and that happened at negative 3, negative 2. Here's a local max at 0, 3. And here is a local minimum at 2, 0. And here I've got a local max at 1, 2, 3, 4, 4, 1. So hopefully that's fairly easy. Extrema means max or mins, or does the graph turn somewhere. I just did something with my hand, and you didn't even see it. It's like radio. Alrighty. So the next thing I want to look at is how many max and mins can a graph have. And this picture, these 3 pictures tell you all of the possibilities of if your function is a 4th degree polynomial. 4th degree plus some other stuff. These are the only possibilities. We know that a 4th degree polynomial that has a positive leading coefficient goes up and up. These are the only possibilities in between there what can happen. The graph could turn 3 times, it could turn 3 times in this way, or it could also turn just 1 time. So it looks like at the most you can only turn 3 times for an x to the 4th graph. Alright, if you were to graph an x to the 5th, I'll let you guys try some of them, but here's a basic x to the 5th. It could do that, or it could do this. I'll let you draw the other possibilities. It could actually end up turning this too. Anyway, an x to the fifth can turn at most 4 times, so you can only create 4 relative extrema. So this little theorem here says that a polynomial of degree n can have at most n minus 1 relative extrema. So if you can figure out the degree of the polynomial, then one number less than that is the maximum number of turns. It doesn't have to turn that many times, but it can only turn that as a maximum. Okay. So the next thing I want to do is talk to you about on the graphing calculator how to investigate this. So what we have is a picture of x to the fourth plus x cubed minus 16x squared minus 4x plus 48. And what we're going to do first is figure out a really good viewing window. And that means a good picture, x min, x max, y min, and y max to see a graph of it. I am not happy with this graph because I've got some gaps here and I've got a gap up here. I do, however, see the correct in behavior because an x to the fourth goes up to the left and up to the right. So I know that I'm good out to the right and to the left because I see that behavior. But what I'm missing is what happens lower than this number, negative 10, and what happens higher than that value, positive 10. I don't need to see further left and right because I already see the correct in behavior. So I'm going to go to my window and I'm going to adjust my y min and my y max. My y min is how far down I look and my y max is how far up I look. So if I change my y min to, let's say, negative 20 and then my y max to 20, and I'm going to adjust my x min and x max as well because I actually didn't need to see further left than what I was looking because I saw the correct in behavior. And you can see in this picture here, that helped out a little bit, but I still can't see down far enough, and I still can't see up far enough. So I'm going to go down and change this from negative 30, and it looks like I need to see a lot further up. So I'll adjust my y max to be like 60. Let's see if that helped. Okay, it looks like it helped a little bit. I can almost see this turn, but I definitely still can't see that other upper turn. So I'm going to look. This is like just a process of elimination. Negative 40, and then it looks like 60 might be okay. Oh, looky there. Okay, so I've adjusted my y min and my y max until I've got a pretty good picture. I know this is a complete picture of this graph because it's an x to the fourth, leading coefficient positive, even degree. That means it goes up and up. Nothing else happens. Plus I've got 1, 2, 3, 4 roots. That's how many roots you can have for an x to the fourth. If you were to factor it, you could have like at most 4 sets of parentheses. And I see the maximum number of turns. X to the fourth can turn at most 3 times. So let's graph this and see if we can't find the value of the max and the min. So what I'm going to do is I'm going to notice that this relative minimum happened, it looks like between negative 4 and negative 3. So I'm going to hit on my calculator second trace. This is going to take me to my calculate menu. Second trace, and I want to find a minimum. This first point down here, this first point is a minimum. So I'm going to calculate a minimum. So I'm going to hit number 3, and what it wants for, first of all, is a left bound. So my left bound, 1, 2, 3, 4, I'm just going to type in negative 4. So this is giving my calculator a little window for where to look, and I'm going to hit enter. And then my right bound, I'll just do negative 2. This is giving my calculator a window for where to look. Take a look at these arrows. My calculator is only going to look between negative 4 and negative 2. And then the guess, you can just sort of zoom down to about where the minimum happens. Not really necessary, and hit enter. Alright, this graph has a minimum at negative 3.1723 and the y value is negative 30.97722. So I would write that in ordered pair. I would write that. I don't know if I can write on this screen here. Can I? Oh, I sure can. Negative 3.17. That's good enough, 2 decimal places. Negative 30.98. This is a relative minimum. Let's see that again, and let's go find this maximum value. Now, this maximum value happens between negative 1 and 1. can see that that window right here, it happens between -1 and 1. So I'm going to, on my calculator, hit second trace. Oh, I have to hit the pointer now, sorry. Hold on, pointer. Okay, I wrote on my calculator. Second, uh-oh. I might have messed up here because it won't let me click on things here. Do I have a little selector tool? Ah! Okay, so we're having some technical difficulties here. I'm going to minimize this and come back up and see if that will help. Second, there we go, trace. This time we're going to find a maximum, that's number 4. And I see that the maximum happens between -1 and 1, so I'm left bound, I'm just going to type in -1, enter. Right bound is going to be +1, enter. And then guess, just move the cursor close to where that maximum happens and hit enter. And it tells you that's at -0.123, 48. So I would say -0.123, 48.25. This is a relative maximum. So that's how you're going to do that on your calculator. You're going to find a good viewing window, and then you're going to find your max and mins. And so this is going to complete the puzzle. We'll know end behavior, we'll know behavior at roots, we'll be able to do max and mins, and we're going to beast these graphs. I will see you guys tomorrow.